Okay, AP Calculus AB, Unit 4, Day 3, Worksheet B, I guess you might call it, Part 2. So these are the answers. Number 1 is B, number 2 is B, number 3 is E, number 4 is B, 5 is E, 6 is A, 7 is E, 8 is B, 9 is C, 10 is D, 11 is C, 12 is B. Of course, you got to show work. Multiple choice does not mean no work. So check your answers. Mark them wrong if you got them wrong. Write down the right answer next to it, and then see if you can fix your work. The back had a couple of very old, very smart style questions. So here are the answers. Got to show work, of course. Find the zeros, equation of tangent line, x coordinate with tangent. So this is kind of stuff we've been doing before. And here's a piecewise function for what value is k continuous. Use the value of having k part a if it's differentiable. So we're going to do these. So there are a couple problems on this that we haven't necessarily talked about, but we can try. So if you just plug 0 in here, sine of 0 is 0 over 0. So this is one of those indeterminate forms. Now, you can't really factor the whole out of it. You could do L'Hopital's rule. And I think we're going to talk about this specific case. Derivative sine is cosine. Derivative t is 1. Cosine of 0 is 1. So the answer is 1. It's not really focusing very well. Why is it not focusing now? Okay, that seems right. Okay. Number 2, plug 5 in, you get 0 over 0. But we could cancel the whole out. This one's really easy. And the answer is 1. Okay. You could do a L'Hopital's rule on that also and get 1 over 1, which is 1. Next one, going pi over 4. Sine of pi over 4 is root 2 over 2. Squared would be 2 over 4, 1/2 minus 1. I mean, I could show a little more work. Root 2 over 2 squared minus 1 be 2 over 4 minus 1. 1/2 minus 1. Negative 1/2. Okay, next one. Sine of 0 is 0. Secant's 1 over cosine. And that'd be 1 over 1, which is 1. 0 over 1 is 0. So the answer is 0. Next one. Number 5, let f of x is non-existent. So non-existent means the limit doesn't exist. So there's got to be some issue at 5, like sine of 0 is 0. That's fine. Natural log of 5, that exists. This would be 25 over 10. No problems there. This would be 5 over 0. That could be an issue, right? This one's going to be 0 over 5, which is fine. That's 0. This is the one that has an issue. As you approach 5, it blows up. Okay, number 6. This is something I think I made a reference to in the last assignment, that this is something I think I'll be showing you guys soon, that this is really a derivative. This is the function that we're trying to take the derivative of is sine x, whose derivative is cosine x. And then we're going to plug pi over 2 in. Cosine of pi over 2 is 0. That's probably your best bet. If you plug h equals 0, and you do get 0 over 0, so you could do L'Hopital's rule. All right. Number 7, we have this graph. limit as x approaches c is, well, here's c, approaching it from both sides, doesn't agree, I'd say undefined. It's got to agree. Right? We have piecewise for what values of k is f continuous? Well, for it to be continuous, both sides have to equal the same thing. So we could, you could plug 2 in here and see what happens. Now, I guess this, we get 0 over 0. So we really do need to look at the, we could factor it, x plus 2, x minus 2, and get rid of the whole there. And then if you plug 2 in, you should get 4. So I think we want k to be 4 so that the whole is plugged up. Okay? So 4. Okay. If it's going to be continuous, then you plug 1 in, and you would get 2 times 1 squared plus 3 equals 5. And then g of 1 should equal 5 also. So which of these functions, if you plug 1 in, will give you 5? This gives you 1. This gives you 5 right here, probably C. This gives you cosine of 5, which isn't helpful. This gives you 3, no. This gives you -1, nope. So it's got to be C. Would be the only function that if you plug 1 on both sides, they both agree. 10, if f is continuous on 4 to 7, how many of the following statements must be true? F has a maximum value from 4 to 7. Well, is it continuous? Yes. On a closed interval? Yes. So then extreme value theorem says you have to have a max, you have to have a min. Does f of 7 on the right side have to be bigger than 4? No, it could be. As you approach 6 limit, will it equal the actual valued function? Yes, that's the definition of continuity. So it's got to be 1, 2, and 4. So how many of the statements must be true? Say 3 of them. Next one, this is derivative. This is just another way of writing the derivative. It'd be 6x. Now, some people might say 3, 4 squared. Nope, that's just a number. So it's just going to be 6x. And let's see. This one's kind of an interesting one. We haven't talked about this yet, but this means the inverse function. So one way we do this is you could find the inverse, which is something you guys were taught how to do at least in algebra 2. And so that's kind of one of the basic ideas for an inverse function. It's a function that undoes the other function. And the way to find them is to swap the x's and y's and then solve for the new y. So this is the inverse function of the original function. So that's g superscript -1. That means inverse. So then if we want the derivative of it, we take the derivative of it and we just get 1/2. So, okay. Got a couple problems on the back. 1981. Okay. All right. So let f be the function. Find the zeros. That's really kind of an algebra problem. Find the zeros means when is the function equal 0? In other words, what are its x-intercepts? So now this is a quartic. So I think we have to use rational root theorem. Well, I don't know. Can we? Well, no. Maybe we could get creative here. Let's think of this as a quadratic, but with x squareds in there. So then it would be x squared minus 1, x squared minus 2. That works. And then we could factor these even further, difference of squares. So you could do rational root theorem. It'd be a bit of extra work. I mean, this is for sure way quicker. So the zeros are -1, 1, root 2, negative root 2. zeros. B says, write the equation of line tangent to the graph at x equals 1. So we want the tangent line at x equals 1. So you need two things. You need a point. Point's easy to get. You just plug x in. You have the x value. You need the y value. So that'd be 1 minus 3 is negative 2 plus 2 is 0. So 1 comma 0 is your point. You need the slope, which you get from the derivative. 4x cubed minus 6x. And then we plug 1 into that to find the slope. 4 minus 6 is negative 2. So that's your slope. So then we do y minus 0 equals negative 2 times x minus 1. Point slope form. That's good enough. Just leave it. Leave it. I mean, you could write it like this instead. You could write it like this instead. But any extra work you do is more time you're spending on it. And any mistakes you make, you're losing points that you already earned. C says, find the x-coordinate at each point at which the line tangent to the graph is parallel to this line. So tangent parallel to y equals negative 2x plus 4. So parallel lines have equal slopes. So we got to figure out, where does the tangent line have that same slope? So all we need to, we got to take the derivative, which we already found before, but I could rewrite it, and set it equal to negative 2 and figure out when that happens. So we got to solve this equation, move everything inside, one side equals 0. We could take 2 out. Should make any technique we use next easier. Okay. Now, I think we got to do rational theorem. So P over Q equals plus or minus 1 plus or minus 1/2, right? Over this is your P values. These are your Q values. So in your head, plug them in until you get a 0. So if I plug 1 in, I get 2 minus 3 is negative 1. Oh, positive 1 works. So I'm going to do synthetic division. 2, 0, negative 3, 1. Drop. And I should get a 0 at the end. Otherwise, I pick something wrong. So this is now x minus 1, 2x squared plus 2x minus 1 equals 0. And hopefully at this point, we could just factor this one without using, we don't need to use rational theorem, but we need pair terms that multiply together to get negative 1. So one of them's they got to both be 1s. One's negative, one's positive. How do we get 2x? We can't. That's fine. We just got to use quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. So negative 2 plus or minus 4 plus 8 So we have x equals 1. We have x equals negative 1 plus root 3 over 2. We have negative 1 minus root 3 over 2. So we have 3 answers. Okay, there you go. Next one is piecewise function. For what value k will f be continuous to x equals 2? So this is like a problem that we just did on the front. So for continuity, the y values have to be equal when two pieces, meet at x equals 2 specifically. So we would, I'd plug 2 into both of these. This is a lazy way of doing the limit. And you get 5. And if you plug 2 in here, you get 2 plus k. And then these should be equal to each other. So 5 equals 2 plus k. That's one relationship. And so then k equals 3, right? Now, a more technical approach, which you should be technical on free response, is to say the limit as x approaches 2 from the left of f of x equals the limit as x approaches 2 from the left of 2x plus 1, which gives you 5. And then the limit as x approaches 2 from the right equals the limit as x approaches 2 from the right of 1/2 x squared plus k. That gives you 2 plus k. And these should agree with each other. And they should also equal. So anyway, same answer. Okay. B says using a value found in part A, determine whether it's differentiable there. So for differentiability, the slopes must be equal. And it needs to be continuous also first. There's got to be a smooth transition now. Continuity just means they're connected. So I would find the derivative of the piecewise function and actually the k value doesn't matter. And you would set these equal to each other. Or yeah, well, and then we could plug 2 in and we get 2 and 2 and they're equal to each other, so that's good. So that's it's differentiable. Now there's a little more technical way of doing it. I'm not going to get into that right now. C says like k equals 4, determine if f is differentiable, x equals 2, justify your answer. Now, if k equals 4, then your function is like this. Okay. And the temptation is to check if the slopes are equal, which they will be. But that's not enough. You have to check for continuity. You should check for continuity first, because otherwise you're just wasting your time if it's not continuous. So if we plug 2 into this, they are not equal, so it is not continuous. So therefore, it is not differentiable. Now, there are more technical ways of showing this work, but I don't think we need to worry about that too much. Now, if you look at my solutions online, whatever, if you look these solutions up, you'll find out. You can kind of see what the more technical is. But for now, I think this is good enough just for us, for our understanding.